So now let's continue with the topic, how to make an alcohol. Next, we will look at this alcohol. How to make it? It's our target molecule. So identify the functional group. It's an OH, and more specifically, it's a tertiary alcohol. Based on what we have talked about, we can make alcohols from the reactions that on our list. First one is addition reaction. To get the starting material for addition reaction, we need to put the double bond around the carbon where the OH is. We have 3 carbons around that carbon, that tertiary carbon. So you have 3 choices, right? You can put the double bond on the left, on the right, or between the methyl and the tertiary carbon. So we have 3 possible starting material, 3 possible alkenes that can all give the same tertiary alcohol if we do either acid catalyzed hydration or oxymercuration demercuration reaction. Both of the reaction follows Markovnikov's rule, so the OH will be attached to the tertiary carbon. Regarding using substitution reaction to make a tertiary alcohol, we can start with a tertiary alkyl bromide. This reaction will work because it undergoes SN1 mechanism. It's the Salvalysis reaction. So that's the only reaction you don't have to worry about the competition of E2. Reduction. Can we make a tertiary alcohol with reduction? No. So tertiary alcohols cannot be made by reduction. Reduction won't work. Lastly, Grignard reaction. So if we want to make a tertiary alcohol by a Grignard reaction, we have 3 possibilities. So to get the starting material, what we need to do is to break the carbon-carbon bond next to the OH. And we have 3 choices here. So I labeled them as A, B, and C here. Alright? So on the next slide, I will give you the starting materials, 3 sets of starting materials that can make the alcohol. But I want you to pause now and see if you can get the correct structures before you check your answer on the next slide. So here are the answers. I put down carbanions and the carbonyl containing compounds. So you can treat those carbanions as all Grignard reagent. And the starting material to get them will be from the alkyl halides. And please note that all the carbonyl containing compounds are ketones. Ketones makes tertiary alcohols. Alright, now lastly, I want you to take a look at this tertiary alcohol. This alcohol has 2 identical groups attached to the carbon with the OH. Okay, it's a tertiary alcohol. It has two identical groups attached to the carbon with the OH. So we can make this alcohol by Grignard reaction. Unlike the previous case where we have 3 sets of starting material, for this one, if you want to make it from ketones, you only have 2 sets of starting materials, right? So here they are. But we do have one more method to make this tertiary alcohol by Grignard reaction. Our starting material could be, instead of ketones, we could make it from esters. So if you still remember from last class that we can make alcohols from esters. Esters can react with 2 equivalent of Grignard reagent to make tertiary alcohols with 2 identical groups attached to the carbon with the OH, right? So here we go. We can use 2 equivalent of the Grignard, and this Grignard will contain the alkyl groups that are identical in the previous alcohol. And for the esters, here we have the methyl attached to the carbonyl, and this methyl is part of the methyl with attached to the C with the OH. And in the ester part, the OR group, it could be anything, right? Because in the reaction, this OR will leave, so it doesn't matter. You can put a methyl, the R group could be methyl, ethyl, any alkyl groups, basically. So I want you to work out the mechanism of this reaction right here. When we have 2 equivalent of ethyl magnesium bromide reacting with an acetate. Okay, work out the mechanism and see if you will get the same product, the tertiary alcohol that we worked from.